Hey everybody, in honors pre-calc, today we're going to be doing the second half of the lesson 4.3 notes, trig functions and the unit circle. For this, you're going to need to just continue the notes where you left off. So if you have a printed copy, you can continue this, or if you're writing it on a separate piece of paper, that's fine too. You're also going to want to have a unit circle. I have mine that I filled in class right here. If yours is usable long term the way that you wrote it when we were in class, then awesome, you can do that. If you need to find a new one to either save on your computer or to print out that's already filled in so you can use it long term, that's fine too, whatever you need to do. But we're just going to pick up where we left off. So we talked about example 1 in class where we said you start with the angle, and if you do the sine of an angle, the answer is the y value of the ordered pair at that position on the unit circle. So if we were looking at pi over 6, the y value would be 1/2. The x value would be root 3 over 2. And so what we do is we just kind of fill in based off of, these trig functions that we also listed. And that's what we're going to do in example 2. So example 2 introduces the idea of the period. And a period just means that angles eventually are cyclical in nature and they kind of go back to where they started. So if we're trying to evaluate a trig function of an angle such as negative pi over 3, right? That's not an angle that's on our unit circle. We only have angles that go from 0 to 2 pi. But negative pi over 3 is coterminal with an angle that is on the unit circle. Meaning, remember, if we add or subtract 2 pi, it still ends in the same spot. And for our purposes of trig functions, that counts. So what we're going to do here is take our negative pi over 3, and since it's negative, we're going to add 2 pi to try to get an angle that's on the unit circle. And so I'm going to find a common denominator, which is going to be 6 pi over 3. So I end up with 5 pi over 3, okay? So that is the angle that is on our unit circle. So to answer these 6 questions, the sine, cosine, tangent, cosecant, secant, and cotangent, we are going to use the angle 5 pi over 3, which is right here. And that is in the same spot as negative pi over 3. So the ordered pair is the same. So the sine is going to be the y value, which is negative root 3 over 2. The cosine is going to be the x value, which was 1/2. Tangent is y over x. Now I'm going to give you a little secret here, let you in on a little secret. To do y over x, think about our unit circle. If we are dividing 2 fractions and they both have the same denominator, the denominators are always going to cancel out, right? The 2's are always going to cancel if we're dividing. So when I divide ordered pair values from the unit circle, I only really think about the numerator. So if I'm going to do y divided by x, I just think about negative root 3 divided by 1. It makes it way easier. And then the answer is just negative root 3. Okay? For cosecant, secant, and cotangent, we just flip those. So this one's going to be negative 2 over root 3, which reduces or simplifies to negative 2 root 3 over 3. We'll make sure it's clear that that's different from the work on the right there. For this one, we flip the 1/2 and just get 2. And then for cotangent, we get negative 1 over root 3, which becomes negative root 3 over 3. And just to remind you, these are pronounced cosecant, secant, and cotangent. Okay? So B and C are actually a little simpler because we do have to use the period, 2 pi, to find an angle that's on the unit circle, but then we're only asked for one of the trig functions, not all 6. So for 13 pi over 6, 13 pi over 6 is bigger than 2 pi, right? 2 pi would be 12 pi over 6. I'm actually going to subtract 2 pi, which is 12 pi over 6, and we get pi over 6. So 13 pi over 6 and pi over 6 end on this same spoke, right? 13 pi over 6 goes all the way around and then to this line right here, which, will give us the same trig function. So What that means is that the sine of 13 pi over 6 equals the sine of pi over 6, which equals the y value at that ordered pair on the unit circle, which is 1/2. We're going to do the same thing for letter C. This one starts negative. It's cosine of negative 7 pi over 2. So we do negative 7 pi over 2. If we add 2 pi and we want to have a common denominator, it's going to be 4 pi over 2, which gives us negative 3 pi over 2, which unfortunately is still negative, right? It's still not on the unit circle, so we're going to have to add 2 pi again. And now we get pi over 2. Lucky for us, pi over 2 is on the unit circle, so what that means is that the cosine of negative 7 pi over 2 is the same thing as the cosine of pi over 2. So cosine, if we look at our unit circle to decode this, cosine is the x value. We're looking for pi over 2, which is right up here. The x value is 0. So the answer is 0. Okay? All right. We are almost done the notes. Example 3, using a calculator to evaluate trig functions. So to evaluate, we're going to make sure that our calculator is in the correct mode, either degrees or radians. Let me set up my calculator here real quick. So if we go to mode, you can see I can switch between radians and degrees. If you're using a different type of calculator, you might need to look up how to do that. But for this first one, we are in degrees. So I'm going to switch to degree mode. And then I'm going to type just right on the home screen, sine of 76.4. And I get 0.9720. I'm going to round to 4 decimal places. And that's an approximate answer. And then for part B, you can see there's no degree symbol. So this is going to be in radians. So I'm going to write that down. No degree symbol means radians when we're talking about an angle inside of a trig function. And we also don't have a cotangent button on our calculator. Now this is often confused. So let me make sure that I emphasize this. When we press second tangent, we're doing the inverse tangent function, but that is not the same thing as flipping tangent to become cotangent. So tangent is different from cotangent, well, obviously, but tangent inverse is different from cotangent. Cotangent, if you look at our unit circle, we saw that cotangent was the flipped version of tangent. So if we want to solve this, we can write it as 1 over the tangent of 1.5. And the reason that's helpful is on our calculator, we don't have a cotangent button, but we do have a tangent button. So I can type this in, first of all, in radian mode. I can type it in as 1 divided by tangent of 1.5. All right, so I'm going to get 0.0709. And there we go. Okay, so that is how you use a calculator to evaluate trig functions. So hopefully that gives you a little bit more of a taste of how we do all of this. Don't forget the period is 2 pi. You're going to have to use that a lot on the worksheet. But yeah, so that's it for today. Thanks for watching. Good luck with the worksheet. And as always, let me know if you have any questions. Thanks.